Okay, let's see. Looks like an easy one that I previously solved. Transformed array. Given an integer array nums that represents a circular array. Circular array is just one where there's adjacency between the last and the first element. Your task is to create a new array result of the same size following these rules. For each index I, where I is an index in the array, perform the following independent actions. Nums at I is if the value nums at I is greater than 0, start at index I and move nums at I steps to the right in the circular array. Set result at I to the value of the index where you land. If nums at I is less than 0, start index I and move app's value nums I steps to the left. Set the result at I to the value you land. If nums at I is equal to 0, set the result of at I to nums at I. Return the new array result. Since nums is circular, moving past the last element wraps around to the beginning. Sure. So 3 is positive, so it moves right 3. Interesting. So 1, 2, 3. Negative 2 is negative, so it moves left 2. So 1, 2. Nums at 1 is negative 2, so we move left 2, we search for nums at 3, so the result should be 1. Oh, I see. So here, you're moving it, finding the value, and placing that value back into the original nums at I, or original index. Okay. Interesting. Okay. So I think it's just requires you have the correct indexing of where you want to look at in your other array. So let's say we'll just leverage the fact that Python can use negative indices to represent the back end of the array. N is equal, do I need N? Can I just use an answer array? I think so. Okay. No, you need to use N. Yeah. I'm definitely going to use a for index loop for every index in range of N. And the value here is going to be nums at this index. And then I need to find this is kind of the displacement. So let's say the movement. Yeah, that's the movement. And then the value that I want to place here is going to be determined by this movement in the original array, right? So -2 from here, so it'd be, I can use modulo actually, right? I can use modulo to make sure that's within a certain bounded range. Nums at index plus value mod n, and then answer appends this value. Interesting. Value is not associated with the value. Oh, oops, index plus the movement. What is going on? Okay. I think because this is I like the decomposition of the ideas, although I think it might need to be slightly... Okay, like this is the decomposed idea with more variables declaration. There is going to be a shorthand version of that. It's answer pen the value that you get, which is going to be nums at index plus the movement, where the movement is nums at index mod n. So this is the decomposed logic, and this is the shorthand, which again, I wouldn't expect people to code with abbreviated logic or abbreviated statements, but it is going to be faster. Okay, interesting. How can you go faster than this, really? I wonder. You can do a list comprehension for this, maybe? Yeah, you can probably do a list comprehension. Okay. So let's try the list comprehension here. It'd be answers equal to I guess it's just the whole this for loop, but in the list comprehension structure. So it'd be nums at index plus nums at index mod n for every index in range n. And this is the for loop. Wow, can't type. For loop version. And this is the list comprehension version. Never really did understand why it's described as list comprehension. Oh my god, it's still slow. Guess I don't need this, right? Guess I can also don't need this, I can just return this. Guess in this version it'd be answers equal to empty array, return answer. Okay, if this is not fast, what the flying fudge? Wow, I don't know. I don't know. Interesting. It's not fast enough. Alright, let me try to run it one more time. Oh, okay, so it's just random. Interesting. Alright, I don't know. Did some slight variations of the same underlying logic. With random runtime output. Overall, need to best to decompose the logic into bits, get the value at the index, at index in array, we'll call that value movement, since it refers to since value also since that value indicates the movement of where to find the actual resulting value. Use modulo logic to ensure that new index is within bounds of 0 to n minus 1, and then store the appropriate resulting value in the answer array. Can use list comprehension to get randomly better or worse runtime. All right. Yeah, so the decomposed stuff is this right here. This should be pretty straightforward in terms of what you're doing. Time complexity is O of n to iterate over every index in the array and find the appropriate resulting value. Space complexity is O of 1. Since no extra space is needed, you don't count the space that is part of the answer. I guess you could maybe modify. No, you can't modify nums while trying to find what the resulting array is and then return nums. Oh, whatever.